Good day everyone, and welcome to the GTAC Tech Talk webinar on the Security Center Network View configuration. Thank you for joining us today. My name is Derek. I'm a technical training e-content specialist with Genetec, and I'll be hosting the webinar for you. We also have Nancy joining us from the Genetec Technical Assistance Center today, who will be helping with the questions and answers during the webinar. Any questions can be typed in the question box of the GoToWebinar console, and one of us will get back to you with an answer as soon as possible. In case we need to verify any information for your question, we'll make a note of it and we'll get back to you via email as soon as we have an answer. All the questions and answers from the webinar will be posted on the GTAC Tech Talk section of the Genetec Technical Assistance Portal forums about a day or two after the webinar has finished. If you have any additional questions or comments on the webinar, or the GTAC Tech Talk webinar series in general, you can post them in this section of the GTAP forum as well. Like all the webinars, this webinar is being recorded, and all the videos can be found on the GTAP by going to the Resources section, and then go into Videos, and go into GTAC Tech Talk. You can either view the video as a streaming video in a web browser by clicking on this icon here, or you can download a zipped Windows media file by clicking on the second icon right here. Now, one other new way that we can watch this video and other GTAC Tech Talk videos, how-to videos, and operator training videos is the new Genetec training channel on YouTube. All the previous videos from the GTAP have been uploaded to the channel, which can be accessed from your desktop PC or a mobile device as well. Please check it out. Just search for Genetec Training on YouTube. Now, if you would like to receive emails concerning the latest additions to the Genetec Technical Assistance Portal, you can log into the GTAP, go into the My Account section, go into Email and Notifications, and then from the Notifications section below here, check the boxes of the subjects you were interested in, and then just select how often you'd like to receive an email when there have been additions to these subjects. To put a checkbox next to a subject, the frequency will have to be set to daily or weekly. Otherwise, if you have it set to never, the checkboxes here will be grayed out. And of course, if you do make any changes, don't forget to hit the Submit button on the bottom to save your preferences. Now, before we get started, I wanted to talk a little bit more about what we're trying to accomplish for this webinar. Now, the general goal of the webinar is basically to get a better understanding of what the network view does and how to configure it. Now, examples are always nice, so we wanted to make sure we give a few scenarios and how you would set those up in the network view and how the system would be handling the information. While we're at it, we wanted to also give you a basic refresher on some of the networking information you'll need, like the difference between unicast UDP and multicast. The last thing was to present any problems you might run into that involve the network view. Looking at the agenda for the webinar, we're going to talk about the basic functionality of the network view first, and then we're going to move on to the talk about some network information, some basics here that you'll need. And then once we have that taken care of, we can move on to the components of the network view and how the network view is used in Security Center. Now we're going to take a look at some related networking information you might need after that, including a multi-NIC setup and what is needed for sending traffic over VLANs. And finally, we'll end with a few troubleshooting steps that could be helpful if you're having streaming issues going over your network. Now, one thing that we've added recently to the GTAC Tech Talk webinars is a table of contents on the side. So you'll see everything from the agenda is here. And if you have to go back and review the video, it'll be an easy way to skip through and find the subject that you need that we're talking about at the time. So keep an eye on here, and you'll see the time marker progress through here. And you can basically review a lot quicker, or if you have to step away, you can tell what section we're in when you come back. Alright, the first thing I want to take a look at is the basic function of the network view, why it's there, as well as some common misconceptions about it. Now, put very simply, the network view is a roadmap that Security Center uses when navigating your network. It's used by the media router and redirectors to know how to pass video over your network and what kind of network traffic can be handled by the network and between servers on different networks. The tree represents your total network information here and how the information flows between different networks and servers. As we add servers, they're added to the list of new networks, and we can add new networks if we need to. And these networks can also be managed by ourselves from this view. Now, bear in mind we don't have much to do here if all our servers and entities reside on the same network. We would only need to add and configure more networks in the case where we have our servers on multiple networks, or we have users accessing the system over the internet. So for example, if we had a closed network with 15 cameras and 3 servers, and it's all within a 10.0.17 network, we wouldn't need to set much up here. Now our default network is always the root, and it's automatically created, and we would have another network created underneath here that holds all our servers in the network view. So looking at the network properties for the 10.0.17 network, we would just need to define what kind of traffic we'll be passing inside the network, and basically we're good to go from here. Now, in a case where we had one of our servers in a different location that had its own network, then we'd have to start taking a closer look at things and making some changes to the network view. So if our main server and an expansion server are on the main network here, let's say it's our 10.0.17 network, and we have a third server on another network, like the 10.1.20 network, we would need to have another network entity defined for the third expansion server. This way, the Security Center system would know how to handle the traffic coming to and going from the third expansion server, and we could also specify how to handle it from the network entity itself. Now, in case there are any client workstations that are accessing the system over the internet, we could define them on a third network, or we could just use the default network to handle these connections. I just want to note the color scheme that we're using here. Anything you see in blue here is using unicast TCP, like the client connection coming in over the default network. Anything in green is using unicast UDP, such as the inside the networks here is all done in unicast UDP, and the connection between them is unicast UDP as well. And if you see anything in red, that's multicast, so we'll go over that in a little bit. Okay, I just want to touch on a couple of common misconceptions about the network view. The first one I want to address is that the network view is just a network diagram, and it's used to view what the network looks like based on the automatically created servers and network entities. Now, this is really only half true, as it does represent your network, but it's used as much more than a visual indication of the network layout. The network view is actively used by Security Center to route the flow of traffic over your system. So this really needs to be set up correctly, or the traffic will not take the most efficient path over the redirectors, or may not get to its destination at all. Now, the other misconception I wanted to bring up is sort of the flip side of this, which is that the network view must have all the servers and networks set up exactly as they are physically in your system. Now really what is shown in the network view is a functional representation of your network, but it doesn't have to be literal and show every little thing. So if you have two networks, but both use the same kind of traffic over the same hardware, you can merge those into one network entity in the network view and put all the servers from both networks under one network entity. This is only in cases where there would be no functional change in doing this within Security Center, and it's really only used for streamlining and simplification purposes. So for example, let's say our main network is here, our 10.0.17 network. And in another building we have two networks. We have the 10.1.20 network and 10.1.21 as well. Now each one of these has an expansion server and some IP cameras. Now if we wanted to be exact about this, we could have a network entity created for each one of these networks, and the expansion server would be placed underneath that network entity. Now let's say the network connection going over to the other building is only unicast TCP. Note that it's in blue here. Now we'll take a look at what this means in the next section, but for now we just need to know that this isn't the best thing for our video flow and efficiency. So if we take a look at our network view here, we've defined the flow between the main network and these two networks as unicast TCP. So the correct type of traffic, network traffic, is used when communicating between the networks and the main network here. Now, what would happen if we make some changes on the network infrastructure and the path between these networks is upgraded to a unicast UDP connection? In this case, we'd have to go into both of our existing networks and make some changes, even though there is functionally no difference between them and they're both using this unicast UDP connection now. A better way to organize the network view would be to eliminate the 10.1.21 network entity and configure the 10.1.20 network entity to handle both expansion servers. In this case, we would only have to make a change to one network entity when the physical network infrastructure has been upgraded. Now this cuts down on our time to make modifications, and there are less chances of making a mistake or missing a network in some cases. Now our example here is pretty simple. It's really not too hard to change the configuration with just the two that we had. But if we're looking at a massive system set up over a wide area network, or WAN, any opportunity to simplify the configuration process would really be encouraged. Okay, I've mentioned the traffic that goes between networks, but I want to take a few minutes just to outline the different types you might see and the differences between them. This is something we'll have to define when we actually set up our network view entities, so I want to cover this before we move on to the configuration steps. So the three basic network communication types that you'll see are unicast TCP, unicast UDP, and multicast. Unicast implies that there's a single sender and a single receiver on the network, as opposed to multicast, which goes from a single sender to multiple specific receivers, or broadcast, which goes from a single sender to everybody. Now you really want to avoid a broadcast environment, as this is the least efficient way to use a network, and you'll usually run into problems if a network entity is broadcasting its data. The flood of information will use up the network resources really fast that other network entities need, and basically it's just going to cause a traffic jam on your network. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol, but really that's probably the only time you'll ever hear those words uttered, and everybody just calls them TCP and UDP. Now the main thing to know is the difference between the two. So the way TCP handles the unicast communication is by checking if the receiver got the packet that was sent. Now this is more stable, as it will resend the packet if it doesn't get the response within a time limit, but there is more overhead involved in the process. UDP here is more of a fire and forget kind of transmission. The packet is sent to the single receiver, but there's no check to see if it got where it was going, and the packets are just sent as soon as possible. For something like video transmission, this is much more useful as there's less overhead for the large amounts of data that are being sent, and if a packet is missing, it is generally not the end of the world, and the image can still be processed. Looking at multicast, this is really taking the whole system to the next level, where the packets are sent to multiple receivers, and similarly there's no check to see if the packet made it to the receivers. Using multicast, packets only go to the receivers that request them, so it's very efficient and doesn't cause excess traffic on the network. Now there are some extra features that you're going to need on your hardware to be able to use multicast communication on the network, which we'll take a look at in a minute. So just to give you a good idea of the difference between the three communication methods, let's consider an example using a single client requesting a recorded video stream from an archiver and multiple clients requesting the same video stream from the same source. Using unicast TCP as the communication method, the client will request the stream, which is always done in unicast TCP, as we can see from our legend here, and the video will be sent from the archiver. Using TCP, the packet will be sent, and the archiver will expect an acknowledgement from the client that it got to the destination. Now looking at the same thing in unicast UDP, the request is made using TCP, then the video packets are sent from the archiver in UDP, but there's no acknowledgement, so it just keeps going. Let's consider multicast finally, and again the request comes in using TCP, and the single stream will be sent from the archiver. Now, functionally, we can see that it's doing the same thing as unicast UDP, only sending one stream back and not waiting for a response. So in actuality, Security Center would use a unicast UDP stream in this case if both sides support this type of communication. Now let's take a look at the same example, but we're going to use multiple clients. And this is where you'll really see the differences in the network load between the three communication types. So starting with unicast TCP, if we have three clients requesting the same stream, these three here, we have the request coming in using TCP, but the archiver will have to send out three independent packets over the network for each one. Now not only that, but we'll wait for the response from each, meaning we'll have three responses coming back as well. So you can see this kind of load we've got going between the switch and the archiver here. Looking at unicast UDP, we will also have the TCP stream requests, and then the three independent streams will be sent in unicast UDP. Now we can see here this is already lighter as we aren't getting any responses back over the network, and the archiver doesn't have to worry about the acknowledgements, it just keeps sending those three streams. Finally, let's see what multicast does. This is really where you get the best network efficiency and is the best choice for streaming video. Once again, we have our TCP request coming in, but here's where the extra network hardware that we have on our switches comes in. Using multicast groups, the switches along the way can determine who needs to receive the video packets and will only direct it to the clients who requested it. Comparing this to the unicast UDP stream, and we can see how many fewer streams we have going over the network, since this is a smart routing process. So as we can see, we've only got one stream coming from the archiver to the switch here. The switch breaks it up into separate multicast groups, sends it along its way, and it still only has to send one stream, and it's divided each time as it's as needed by the multicast groups. Now, as we mentioned, there are a few things that we need to have on our network hardware to make multicast happen, and if we are missing one of those components, it might turn the multicast into a broadcast, which is generally bad news for anyone trying to view video on the network. You can see here how many extra streams, really sending it to everybody and even the people that aren't even requesting it. So really causing a lot of network traffic here. Now when looking for switches, we first need to make sure that they have enough multicast groups. We need one multicast group per stream that's being sent, which includes separate audio streams as well. Now remember that we can have cameras that are sending more than one stream at a time as well, in case we're using dynamic stream switching, for instance. Now a decent high-end switch would support 256 multicast groups, but on a larger system you might want to consider a switch with 512 multicast groups or higher. Now there are also specific functions that need to be supported on the switch. Each local area network should have at least one Layer 3 device that has IGMP querying supported and enabled. The rest of the switches can be Layer 2 devices, and all the switches should have IGMP snooping enabled. Now there are some switches that are considered Layer 2.5 devices, and those could be used as long as they have enough multicast groups and support the IGMP querying. One last thing to consider is also the speed of the network. Now, as a best practice, we generally want to keep the network utilization under 70%. If all the network hardware has a top speed of 100 megabits per second, and we're exceeding 70% utilization, it would be a good idea to consider hardware that supports gigabit connections. We're going to move back to the network view now and take a look at the entities that are part of it, see what each one does, and how to configure it. So let's start with the network entities, which are the branches of our tree in the network view here. The network entities are used to define our networks and are used to make stream routing decisions for the servers that are associated with them. When you add a new server, if there is no appropriate network defined, it will create a new one. If you want to add one yourself, just hit the Create button at the bottom of the network view tree here. It will prompt you for the name of the network, the description, and of course it'll ask you for the partition to put the entity in. Pretty much everything you'll need to set up from the network entity is done from the Properties tab. The first thing to configure is the Capabilities field, which defines how live video will be streamed over this particular network. The order of networks from least capable to most is Unicast TCP, Unicast UDP, and then Multicast. Always pick the most capable setting that your network can handle, and the ones below it will be included with it as well. So, for example, if your network does not support multicast, but it supports Unicast TCP and Unicast UDP, then like in this example here, we would choose Unicast UDP as our capability setting, which would also be able to handle Unicast TCP. The next step is to set the IPv4 address prefix and the subnet mask as well. Now, if you'd rather specify the number of leading bits to use as the subnet mask, hit the I icon right here, and you can specify the CIDR block display value after the address prefix. In this example here, we want to use the first 24 bits out of the 32-bit total of the mask, which is the same as if we had used the mask of 255, 255, 255.0. Now looking back at our example where we wanted to reduce the number of networks, we had a network that had a prefix of 10.1.20 and another with a prefix of 10.1.21. If all the hardware was shared on these networks and it is more of a logical distinction, we can instead create one network instead using the prefix of 10.1.0.0 and have the subnet mask of 255, 255.0.0. Now this would bring the servers on both networks together and any other servers that match the 10.1 prefix. Now using the subnet mask here, we could actually restrict it more if we wanted to. If your network supports IPv6, you can put the network prefix in the next field here as well. Now you will have to have the Use IPv6 option enabled in all of your servers in order to use this type of addressing. This can be found in the server admin, under the Genetec server tab, and in the network section here. So we just need to make sure we have Use IPv6 checked right here. The last two options to set up are to use the public servers and the network routes as well. Now a proxy server is used if your network is being accessed through Network Address Translation, or NAT, and is set up from the public server properties. So we can add a new public server, or we can edit the properties of an existing one to enable the proxy setting. You just need to switch the proxy on here. The server that we select here must have the Genetec server software installed, of course, and have a public port and address that can be reached through any firewalls on the system. The route table below that is how we define the connections between the different networks. For each network that this network is able to reach, we should have a route to define how to connect between the two. The capability of the route should be the lowest of the two capabilities on the networks. So for example, if we had a network for building A, which can support multicast, and we have a network for building B, which the capability supports unicast UDP, we should be using unicast UDP. Now from the building A network, like we have selected here, we would add a route to the endpoint named building B, like we have here, and choose unicast UDP in the capabilities. As you can see, it also takes unicast TCP into account, as we mentioned. Now if you need to add more endpoints that this network can see, or if you need to modify the routes for any existing endpoints, you can use the controls below here. So to select one, you can hit the edit button here, or you can create a new one if you want to. Now if you see any endpoints on the list that cannot be reached by the network entity, that may have been created erroneously or by default, you can just highlight it and just delete it from the route table here. Okay, the next component of the network view that we need to look at are the servers here. Now, servers aren't created in the network view, but are created in the system automatically whenever we install a machine with the Genetec server software and connect it to the main server. If your server has multiple network cards or NICs, each one will show up in the private address list here. You can use the arrows on the side to select an address and change the order if needed. The private address on top should fit with the IPv4 address prefix on the network entity it was listed under. If we need to make any changes to the server admin for this server, we can do this from the third tab here, or connect using a compatible web browser. Servers can be moved in the network view tree by simply dragging and dropping them into the new network that they should belong to. So if we have one that was created under the head office, but we realize this one should really be under the Genetec.com network, I can just click and drag here and drop it into the this network right here. Now by default, a new system has the default network entity, and below that is a network entity for the network the main directory server is on, and within that network is the main directory server entity. The main directory server here, you can see it's the main one because it's got the globe on the server icon for easy identification. Now the default capability set for the main network and any new networks is unicast UDP. All new servers are added under the default network, which is the root of the tree and acts as the network for any connections that do not fit into any of the existing networks we have created. Since it is the root, the default network cannot be deleted. The capabilities for the default network are unicast TCP, since it is a connection type that's common to all entities connecting on any network, but you can select it and you change this in the capabilities if you need to as well. Okay, so we've gone over some of the components and how they'd fit together. But I want to take a few minutes just to show some examples and how this would actually work when setting up, when you have it all set up properly. Now let's take a look at a simple example using multiple networks, and we'll see how some modifications in the network changes things and how we would have the entities set up in the network view. In our examples, the three networks we have set up are the head office, building A, and building B. The first example will have the head office using a multicast connection in the on its network internally, and unicast UDP communication in buildings A and B. So within our network view, our network capabilities would look something like this. Between the buildings, the network supports unicast UDP only, so our routes from the head office would have a maximum of unicast UDP. But of course it would support unicast TCP as well, as we've mentioned. So what we're looking at here is really it's the endpoints when having the head office selected. So just taking a visual look at this, if a client in the head office requests a video stream from a camera in building B, the media router will take a look at the configuration in the network view and find the best path and which network transportation capabilities to use to get back to the client. Now this would be from the camera to the archiver in building B, which contains a redirector by default, then over to the redirector on a server in building A, and to a redirector in the head office. All the requests from the media router to set up the redirectors and the command requests from the client workstation have been going through in unicast TCP. Now since the building A and building B networks only support unicast UDP, and the routes between the buildings here as well only support unicast UDP, everything up to the head office point here will be passing in unicast UDP. Excuse me. Now of course, since the head office supports multicast communication, the redirector will send the stream to the client in multicast. If we had other clients requesting the same stream, they would also get the multicast stream from the head office redirector. If we had a camera in the head office network that we're viewing, that stream would just go directly to the client in multicast, since it's not crossing over to another network, and it's just using the network capability that we have configured for the head office network. The route would only be used if we're getting the stream from another network, and the route capability is determined in the table based on the endpoint or network we're getting the stream from. Now let's change the example up a little bit here. Let's take a look where the hardware has been upgraded to buildings, and now the buildings support multicast. Now the connection between the buildings has been upgraded to multicast as well, but we still have a unicast UDP connection going to the head office. Now in this case, we don't need to use the redirector on the archiver at building B. The camera stream will go from the camera right to the redirector in building A, where it will get sent using unicast UDP to the redirector in the head office and sent in multicast to the client. Staying with this configuration, what happens if we have a client on a workstation that's trying to view the video stream over the internet? The media router would look at the address of the incoming request, determine that it's outside of the networks that it has previously defined, and this would fall into the realm of the default network. The routes and capabilities there are set for unicast TCP, so the redirector in building A would send the stream out using unicast TCP to the client. Now, just to give you an example of the power of multicast, if that unicast UDP connection that we had here going to the head office was upgraded, and the whole network here, you can see everything is running in multicast, this is what we would see when the video stream is sent. Right from the camera, over the whole network, and straight to the client. No redirectors in use at all here. One last example I want to touch on is using federation. So when streaming video from a federated camera, the media routers on both sides will talk to each other to designate which redirector on the client side should be used. The media router on the client side will let the media router on the camera side know how to access the redirector, and that will be able to efficiently send the video to the client. The media router on the client side treats the request just like any other client request and resolves the route to get the video to the redirector. The video gets sent using whatever capability has been defined for the routes and networks, and goes right from the camera or the archiver through the redirectors and to the client workstation. Alright, so that should give you a good idea of how the routing works with the media router and how it uses the information in the network view. But before we get into the troubleshooting section, I'd like to cover a few other networking subjects that might affect the streams over the network. First of all, I'd like to talk about the network card configuration on the servers when using multiple network interface cards, or NICs. If you don't have the NICs configured properly, with the main NIC taking priority, you may run into problems where viewing live or recorded video and see the dreaded waiting for signal message. The first thing we want to do is get into our network adapters in Windows. So we can do this by opening the control panel, going into the Network and Sharing Center, and then click on the Change Adapter Settings option. This may also be called the Manage Network Connections, depending on the version of Windows that you're running. But really, a faster way to get to this screen is just by opening the Start menu or doing a search and running ncpa.cpl, which will bring up the window at the same place as all the above steps, showing the network adapters that are present on the server. From here, right-click on the NIC adapter that will be primarily used by the services and roles, and choose the Properties option. In the Networking tab, under the list of items used by this adapter, select the Internet Protocol version 4 TCP/IP item and click on the Properties button below the list, or just double-click on the item. From the General tab of the window that pops up, click on the Advanced button at the bottom. And at the bottom of the next window, there's an option that says Automatic Metric. Uncheck this and assign it a value of 1 in the interface metric field. Here we just need to hit the OK button until we're back to the list of NIC adapters. So just repeat the same steps on all the other network adapters you have active on the system, but assign them a value of 20 or higher in the interface metric field. We now need to make sure the network, the priority NIC is the first one in the list of network adapters on the system. So from the list of network adapters, click on the Advanced option from the toolbar on the top of the window. Now just note that this toolbar here, it might be hidden by default. So hit the Alt key once and that'll bring it up on the top here, and you can select the Advanced option. From the Advanced drop-down menu, select the Advanced Settings option. In the list of connections, locate the network adapter we want to use as the priority NIC. Click on it to highlight it, and then use the green arrows on the right side to bump it up to the top of the list. Hit OK until we're back to the network adapter list and close the window. We should now restart the server to make sure the changes take effect in Windows. Now make sure this is at a convenient time where the roles attached to this server can be restarted. Setting the correct network card is important, as any role using the Any configuration for its network adapter will use the primary NIC by default. Now the next topic I want to cover is multicast streaming over multiple VLANs. Now if you want to get video to go from one VLAN to another, you'll need to send the command and control traffic through a routing device, either a router or a Layer 3 switch. On the Layer 3 switch, you'll need to make sure dynamic multicast routing is an available option and has been enabled on the switch as well. As we had mentioned previously, we need to have IGMP snooping enabled on all switches, and IGMP querying must be configured on the Layer 3 switches. The Layer 3 querying is particularly important as it's the function that handles which hosts have requested to join particular multicast groups and ensures that the data continues on to the correct destination. For example, if you're using Cisco hardware, the multicast routing is enabled through the Protocol Independent Multicast Sparse Mode, or PIM-SM. This PIM sparse mode needs to be enabled on the Layer 3 device of each VLAN interface. Using the sparse mode will require using a router that has been designated as a rendezvous point, or RP. This may be automatically configured on higher end equipment, or you can check the specific hardware guide on how to enable this feature on your switches or routers. Alright, so let's finish off by looking at some troubleshooting tips for any problems you might have related to the network view. Let's start out by looking at a problem where we can see the video stream correctly on one network, like we have here, but it's not getting through to the client on another network. Looking at this visual here, we can see that the weak link may be here, the route between the source and destination networks. Take a look at the route table for one of the networks, either the source or the destination. Now make sure the route can handle, or make sure the network itself can handle whatever capabilities have been set in the route between these two endpoints. So if you have a unicast TCP connection, as we're demonstrating here, but we have the route set to unicast UDP as it's trying to be sent, the traffic will just stop basically and not get through to the other network, to the client network. So you can try to reduce the capabilities for the route on either the source or destination side. Whatever change you make here will apply to the opposite side as well. So in this case we have the building B network selected, we're looking at the routes, and we have the endpoint for building A here. So we could just change this to unicast TCP, and then if we went to building A, we would see the building B route here, and it would reflect the change and only have unicast TCP as well. Now another thing to consider using the same example is we need to check if the destination network can handle the capacity set for that network. So the video stream may be getting through the route we have here to the redirector, but the redirector may not be able to get the video to the client if it's trying to use a communication method that's not supported on that network. So in this example here we have the capability set to multicast. So we're trying to send multicast, but we can see that this is actually a unicast TCP network, so that stream's not going to get through from the redirector to the client. Now this would be a good first step to do if you're having problems where the client and the video source are on the same network. So if the camera is over here and it's not getting through, that might be something to take a look at. Now let's take a look at a similar issue on a multicast network. Now if we know the network should be in multicast, but we're getting a waiting for signal message while viewing a camera within the same network as the client, we need to consider the capabilities as well as the hardware. Now of course check the network capabilities first and make sure it has been set to multicast. And just to test, we can actually set the lower this to unicast UDP to see if that video does get through, and to make sure that we know it is a multicast issue for sure. As we have mentioned, we need to have the IGMP snooping and querying supported on the hardware. Now in some cases these options may be supported but may be disabled by default on the network hardware when you receive it. So just take a look at the documentation that came with the hardware and make sure that the options here have been enabled. So this is just a sample here from a particular switch. Now we also need to make sure the switches have enough multicast groups to handle the streams that are going over the network, and that the switches are not simply broadcasting all the traffic as well. To make sure we're testing our client application using the right network, we can actually force the client to connect to a particular network. So from either client application, either the config tool or the security desk, go into the options, then go under the general section here and look under the network options. So under network, select specific here, and then you can use the drop down menu to select the particular network you want to connect over. So this way we know the client and the camera are on the same multicast enabled network and not trying to connect through some other server on another network and bringing a route into the picture for our troubleshooting. Now one last thing I'd like to cover is how to see the route status. Now to view all the routes on the system, we need to run a system status report task and choose routes from the drop-down menu for which entities to monitor. From the report it gives you, it will show you all the possible network endpoints, so all the possible routes here and combinations of them. It'll show you the current configuration we have set up for those routes, and it'll tell you what it's detected in terms of the capabilities as well. And at the end here, of course, is the status, and it'll tell you if it's a good connection or not. Now, just a quick note here, is that the status will only be reported on any routes where there's a redirector server on each endpoint. So any point or any route that does not have a redirector server on both sides, like anything that has the default network as an endpoint, will either show a not available message like this, or a mismatch warning in the status field here. So if you're having any problems getting video from one network to another and think one of the routes might be the issue, this would be a good task to run and check the status and what it's detecting and the capabilities here as well. It's a good, easy way to see if there's any difference between the configuration and what it's actually detected. Alright, so that's the last troubleshooting subject that we had to talk about for the webinar today. So in the next couple of days, we're going to post the video of today's webinar on the GTAP as well as the YouTube channel. And on the GTAP, we're going to put the general questions and answers in the GTAP forums. In the forum section for the webinar that we presented today, we're going to also have a link to the slides in PDF format if you need to go back and refer to anything. Now we're going to keep the session active for about another 10 minutes in case you have any other questions for Nancy or myself. And if you do think of anything you'd like to ask after the webinar has finished, please feel free to post it in the GTAP forums in the appropriate section, and we're going to get back to you as soon as we can. Now, just one thing, when you close the webinar, or when we end the session on our side in about 10 minutes or so, you will be presented with a very short survey, just 3 questions to give us a little feedback on the webinar you attended today. So if you do have a couple of minutes to spare, we'd really appreciate any comments or suggestions you have. On behalf of myself and everyone at the Genetec Technical Assistance Center, I'd like to thank you very much for attending the webinar today, and we hope you all have a great day. Thank you.